What's up, everyone? This is LeetCode 733 flood fill. So I've done this problem in Python. Now we're doing it in C++. So I'm going to try and explain this problem in as simplest as I can, because it is kind of a wordy problem, but it's actually not that difficult. It just looks confusing initially. So we have basically an image represented by an m by n integer grid image where a given cell represents the pixel value of the image. We're given three integers, SR, SC, color, perform flood fill starting on the image from the pixel image SR, SC. To perform flood fill, consider the starting pixel plus any pixels connected forward directionally to the starting pixel the same color as the starting pixel, plus any pixels connected forward directionally to those pixels also with the same color, and so on. Replace the color of all the aforementioned pixels with color, and then return the modified image after performing flood fill. So we're given SRSC and we need to go to image SRSC. In that case, it would be, this is image SRSC. And don't pay attention to the blue and the red. The actual colors are represented by the integer, okay? The blue and the red, the red is just showing that this is the starting pixel, and the blue is just showing that these are the adjacent, they are the adjacent pixels of the same quote-unquote color. The color is actually represented by the integer 1. So we go to image SRSC, which is this red cell here, and the starting pixel color is 1. So we basically need to go to all adjacent pixels, and the adjacent pixels to the adjacent pixels to the starting pixel, and then the adjacent pixels to those other pixels. And if they're the same color as the starting pixels, replace it with color, right? So for example, this one is color pixel 1, which is the starting pixel. Go to the left, go to the right. Well, the right actually is 0, so it's not the same as the starting pixel. This 0 is not the same as the starting pixel. This 1 is, though, and this 2 is, though. So let's replace this 1 with the color, right? So this would be 2, this would be 2, this would be 2. Even before we do that, though, we need to basically check all of them, right? So when we're at this 1, we check left. Well, we can, right? Out of bounds. Right, we already did that. Go up, go down. Okay, these are 1, right? They're the same color. So at the end, these would all get replaced with the color. So that's why this is 2, 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 right? Because when we're at the starting pixel and we go top, right, this gets converted to a 2, so does this. See how this one's a 1, though? It's because you can't connect to anything, right? Because you can only go top, left, down, to the right. Can't go diagonal. So this actually never gets converted. So it is initially confusing to know what's going on, but we're basically just given a starting pixel, and we need to go adjacent, right? And then we need to go to those and go adjacent again, and keep doing that until we touch every single pixel that is the same as the starting pixel, and then we convert all of those to color, which is an input. In this case, color is 2, which is why these 1s all get converted to 2. Okay? So it's not that difficult, but it's a little bit tricky to wrap your mind around when you first look at this problem. So what we're doing is we're gonna basically do this recursively, okay? So let's get the starting pixel, right? And to do that, we get image SR, SC, which are SR and SC are just the inputs, right? For finding the starting pixel. Now let's get the height here, which is going to be image SR 0. Actually, we don't need the height, I don't think. No, we don't need the height. Let's go down here though and just return the image, because at the end of this we should be returning the modified image. So yeah. So we need to basically recursively touch all adjacent pixels starting at the starting pixel. So we're gonna call DFS. We're gonna define this function, okay? But for now, Actually, let's do that right now. We're gonna call this DFS. You can call it fill, you can call it DFS, whatever you want. So in this, we're gonna have to pass the actual image, right? Vector, int, right? This we're gonna pass it this because it's the grid, right? So that's gonna be an input. We need to pass it SR, we need to pass it SC, we need to pass it the starting pixel, we need to pass it the color. Okay. Basically, we need to pass all the relevant information, right? We need to know where we are on the grid, and we need to know what color we need to change it to, and what's the starting pixel color. All of this is important so that we know what pixels we have to change, right? So, in here, for example, we would pass image, we pass SR, we pass SC, we pass starting pixel, and we'd pass the color. Okay. And yeah, that's basically all we need in here. Now we just need to actually do this recursively and fill in the pixels. So first of all, we need to make sure first that we're in bounds, okay? So this is the rows, right? So the rows can be 0 up to whatever the height is, okay? So we're gonna say if the row is less than or equal to 0 and it's less than image.size, and now we need to do the same but for the columns. So we're gonna say 0 is less than or equal to columns, and it's less than the image 0 dot size, because let's say this would be like column 0, column 1, column 2, right? So when we do image 0 dot size, what we're doing is we're getting how many columns are, so it'd be 3. But there's not 3 indexes, there's 2, right? So technically we need to be less than 3, right? Because we can be in column 0, column 1, column 2. We don't want to set this equal to, because there's no index 3 in the columns. There are 3 columns, but there's no index 3, there's index 2, right? That's why we do less. We do less than rather than less than or equal to. Same logic applies for the rows, okay, when we're getting the rows. Okay, so all we're doing here is just checking that we're in bounds of the grid. Okay, now we need to check, okay, if we're at a specific cell that is the same color as a starting pixel, let's convert it to color, okay? So if we're at a specific cell, which would be image SRSC, and that is equal to the start pix, which would be the starting pixel color, okay? That's what we want. And on top of that, the specific cell we on cannot be equal to color, because let's say we start at this one, right? We go to the left here. This is equal to the starting pixel color, because this is also 1. So we convert this to a 2, right? So when we go down, this is equal to 1. So convert it to a 2. Now let's say we're here and we go up, right? Because we check 4 directionally, right? When we go down here, right, we go to the left, that's not in bounds. Go down, that's not in bounds. We go to the right, that's not equal to this here, which is this is not equal to the starting pixel color, because it's 0, not 1. Okay, so we don't go there. Now when we go check top, well, when we go top, that specific cell is not equal to, or it is equal to color, so we would not enter this if statement, because we already converted this to a 2, right? So we don't need to do anything. We're not going to convert a color. We're not going to convert a color to a specific cell to a color, to our input color, when we already did that, right? So this is basically preventing doing double assignments, right? Like it's just like we're just avoiding doing the same thing over, right? Because it just adds like overhead that's we don't want. Makes like our algorithm inefficient. Okay, so that's what we need, right? We need to make sure that the specific cell we're on is equal to a starting pixel. Okay, and we need to make sure that is not equal to color. Okay, so I'm gonna say if that's the case, then let's convert that specific pixel to the actual color. I'm gonna do this. Okay, then after that, we're gonna pass it the image c start pix and color. Let me copy this. We're going forward directionally, right? So we're gonna go, don't mind that, that was an accidental submit. So we're gonna go below the row, above the row, to the left of the column, right of the column. Okay. Well, I think I did something wrong with my input. So we're saying vector, whoops, this should not be there. There you go. Okay, and I mean, these are important because we don't want cases where we're doing double work, right? Otherwise we get Stack Overflow because we're just like repeating and like adding almost like recoloring the same pixel. It's just adding so much overhead, right? That's why these are really important as well. But yeah, this problem is a little bit hard because you need to understand what you're actually doing in order for the code to make sense, but I think I explained it okay. I have done this problem in Python too, so feel free to check that out. But yeah, this problem isn't too hard. It's just like getting you accustomed to DFS. I think you can solve this using BFS as well. You can solve this problem a number of ways, but it's just getting you used to like solving problems recursively, and BFS, DFS stuff, like it is pretty important in harder problems when you're starting to work with matrix problems and stuff. But yeah, I hope this helped anyways, but I'll see you in the next one.